Hello, let's talk about how forests drive water cycles. And the idea is that forests have a lot to do with our water cycles, and the water cycles have a lot to do with our climate. And the purpose of this talk is to heighten our appreciation for what happens when we lose a forest. You know, when you go in with bulldozers or chainsaws, heavy equipment, whatever it is, and you either entirely cut down a forest or you eliminate part of the forest, some of the trees in it, do something called forest thinning, then something is lost there, and let's heighten our appreciation for what is lost. So I'm going to go to my handy dandy slideshow here. The slideshow is forests and water. This presentation is about how forests drive our water cycles and how water flows through forest ecosystems and all the benefits of that. Evaporating water cools the air. So number one in how forests impact our climate, evaporating water cools the air. How does that work? Well, step out of the shower or the pool and it feels cold because there's evaporating water. It's the same when we sweat or perspire. The water is evaporating. That's what makes it cold. And we evolved so that the water that comes out of our pores evaporates and keeps us relatively cool. It keeps us from overheating. Other animals have other methods of keeping their bodies cool. Many animals don't sweat, many do. Horses sweat, dogs don't. Dogs pant, but every animal has especially warm-blooded animals, have means of keeping themselves from getting too hot, and evaporating water is part of that. Now, when you walk out of a forest, or when you walk under a shade tree, or you walk into a forest, you have the same phenomenon. It feels cool, partly because of the shade, but partly because there is a certain amount of evaporation going on. The evaporation takes that heat and turns it into another form of energy that does not feel warm. It's not sensible heat. Sensible heat is what we feel. Latent heat is what is kind of a form of energy that's there, but we don't experience it as heat. So evaporating water cools the air. Now, when you talk about climate, it's all about CO2. The mainstream climate conversation, which I do not embrace, I'm very critical of the mainstream climate conversation. It's all about CO2. It's all about greenhouse gases. Yes, water is also a greenhouse gas, but we're not going to talk about that because we're just not. Because the purpose of the mainstream climate conversation is not to solve these problems. The purpose of it is something else, but the purpose is not to solve problems. But let's talk about the monumental role that water has in solving, in governing our climate, and therefore how we manage our flows of water will have everything to do with what kind of climate we have. Evaporating water takes energy to evaporate. We've already talked about that, so I'm going to go on. Now, another way that forests drive our water cycles is that trees intercept rainfall. Trees, plants, good soil, ecosystems intercept rainfall. And when that happens, what happens when you intercept rainfall? Let me click out of this. What happens when you intercept rainfall? Well, it prevents a flood. And another thing, it prevents drought. And another thing, how does it prevent drought? Well, if you soak that water into the landscape, then the plants have what they need so that they're less likely to experience the effects of a drought. Go here to my handy dandy screen. So trees intercept the rainfall. As opposed to what? As opposed to, this is by my friend Chris Matera, Massachusetts Forest Watch. This is a clear-cut carbon reservation. Boston's drinking water supply watershed is included here. When you cut down these trees, they do not intercept the rainfall, not like they did And so we want less of this and more of our fully functioning, intact forests that are allowed to grow old and mature. Another way in which trees drive water cycles is that trees transpire water vapor. This is what results in the evaporation that we were talking about. This transpired water has a cooling effect. It contributes to the water cycle. For example, future rains, when that water is transpiring. Transpired means it travels from the roots up through the stem, out through the leaves. So when it transpires and then evaporates, it's contributing water vapor to future water cycles. It's also contributing something called condensation nuclei, which we'll talk about in a little bit. And this transpired water prevents the soil from drying out, because the trees and the plants are all transpiring water. They are creating a humid environment. They are a humidifier. It's like if you have a piano or a guitar, you want it to not dry out because that affects it. So you humidify, and some people have humidifiers in their homes. The heater serves as a humidifier because it's good for the environment to be a little bit humid, so as to not dry out too much, because life processes depend on not drying out too much. Another thing that happens as forests drive our water cycles is that the leaves on the ground soak up the rain and prevent floods. So if you have a rainfall that is if you have a 1-inch rainfall, that is, guess what? 27,000 gallons per acre. An acre is not that much land. It's like 200 feet by 200 feet. 1 inch of rain on 1 acre is 27,000 gallons. 2 inches of rain is double that, or 54,000 gallons. So you want the leaves to soak up the rain and prevent floods. If you remove the trees, then you remove the source of the leaves, and you're causing floods by removing those trees. When you have excess runoff, it causes flooding. We're talking about all the ways in which forests drive our water cycles. Excess runoff, flooding is not caused by rain. It's caused by excess runoff. Runoff is more of a human-made, a man-made, or a human-caused condition. And you're going to have more runoff if you have a clear cut like this. We have excess runoff because our land is not the sponge that it could be if we had enough plants and trees. So what I'm trying to do is heighten our appreciation of what is lost if we lose the trees and the forest. We lose flood control. We lose drought mitigation or prevention. Another way in which trees and forests drive our water cycle, plants and trees prevent drought. I've talked about that already, but plants and trees, they improve the soil for one thing. For one thing, they intercept the rain. And for another thing, they put carbon into the ground. When you put carbon into the ground, that makes the soil more spongy and absorbent, so that you're just not going to have the effects of drought, irrespective of rainfall, irrespective of whether you have above average or below average rainfall. You want your landscape to be able to hold onto the water so as to prevent drought. As opposed to what? So right here we said plants and trees prevent drought, and right here, the trees, the plants have been removed from this. So ironically, you're going to have more drought when you clear the landscape and for farming purposes. And somebody says, Hart, farmers have to grow food. Well, this is not growing food. I mean, it's growing a commodity, and commodities are junk food. Sometimes commodities are not food at all. They're just, like corn ethanol is a commodity, and it's not food. Growing corn for livestock is not food. Cattle, for one, are not made to eat corn. They're not made to eat very many seeds. And we just have all this land dedicated to stuff that's not food. So can we talk about how we can instead have a landscape that is biologically diverse and suitable for growing good, nutritious food. Plants and trees improve soil quality. So let's talk about how this works. Plants and trees improve soil quality by taking carbon out of the air and putting it into the ground through the process called photosynthesis. So you take the plants take the carbon out of the air. They, carbon dioxide plus water plus sunlight yields oxygen and sugars. And so they take those sugars, which is a form of carbon. Sugar, your basic sugar, has 6 carbon atoms in it, C6H12O6, and takes that sugars and exudes about a third of them out of the roots, and the fungi and the bacteria come running the cake and cookies, and they're thriving on those root exudates, the substances, mainly liquid, that are exuded from the roots. And so, why am I telling you all this? Because plants take that carbon out of the air, which is a service, but they also improve the soil. And when you improve the soil becomes more spongy, the soil becomes more able to absorb rainfall. And so, and that's a good thing because it prevents both flooding and drought. What else have we got here? So this is the soil food web. We're talking about how forests drive our water cycles and increasing our appreciation for all the things that forests do as they drive our water cycles. And one of them is the soil food web. It's an ecosystem that is underground. The main, this image is from Regenerative Soil by my teacher, Matt Powers. He's I think the single best teacher of soil health today. There are some good ones. There's some names that are well worth mentioning, like Elaine Ingham and John Kemp are 2 other people who are just great teachers of soil health. But this is from Matt Powers. The main categories of soil organisms that are microscopic are bacteria, fungi, protozoa, nematodes, which are microscopic worms, and microarthropods. So that's soil biology. One of the most neglected topics of the last 100 years is soil biology, especially in farming and gardening. I think the single most neglected topic is soil biology. It's really, at one level, it's complicated. At another level, it's not that complicated, but we need this soil food web. Let's go on to the next slide. The soil food web and soil organic matter are the measure of healthy soil, giving it the ability to act like a sponge holding on to rainfall. So we're talking about all the ways in which forests drive our water cycles. They drive the evaporation, the condensation, the cloud formation, and the what's the fourth one? Precipitation. They drive the main aspects of our water cycles. Good soil like this is the home of the soil food web, including bacteria, fungi, protozoa, nematodes, and microarthropods. So, and land that has good soil can hold on to the rainfall, providing water to the plants and trees until the next rain. Only good soil can hold water. Only good soil can deliver nutrients to the plants so that the plants are resilient and nutritious. There are about 20 nutrients that are essential for plants, carbon, hydrogen, oxygen, nitrogen, calcium, magnesium, molybdenum, selenium, boron, manganese. There are about 20 elements altogether that are essential for plants. And why was I talking about what? Because only good soil can deliver those nutrients to the plants. If you go in and you you till it and you use chemical fertilizers, you're compromising the ability of the soil to deliver those nutrients to the plants. But we're talking about forests and water cycles. But I wanted to share with you a little bit about the soil food web, because it's the soil food web that is instrumental, really, in helping maintain a healthy forest, and a healthy forest in turn drives our water cycles. The plants and trees invite rain. I'll do a couple more slides and then I'm just about done. Plants and trees invite rain. So this is kind of hard to understand, but let's just say that rain is going to fall if it has a cool, moist environment into which it can fall. This has to do with moisture. It has to do with barometric pressure. If air that is moist tends to have a lower barometric pressure, and if it's cool and moist, so much the better. And that's how the raindrop can fall all the way to the ground. Plants and trees create a moist, low-pressure environment into which rain can more easily fall. This is just a little cartoon, but what are we talking about here? You see these big raindrops, and those raindrops are only going to make it all the way to the ground. They can make it all the way to the ground under two different circumstances. One is which there's a cool, moist environment that is not evaporating the raindrops before they hit the ground. And the other circumstance is, it can reach the ground if, why do we have these downpours? We have these downpours because we don't have enough biogenic condensation nuclei, and I'll talk about that in just a minute. Let me go on down here. Trees and forests form clouds. So we're talking about all the ways in which forests drive our water cycles, and trees and forests form clouds. How does that work? Clouds don't form on their own. They need condensation nuclei in order to form water droplets. So condensation nuclei includes what? Condensation nuclei includes salt, ice crystals, bacteria. VOCs means volatile organic compounds. Condensation nuclei also includes number 5, pollen and fungal spores. And the thing about these, the number 1 and the number 2 are not biogenic. They're not produced by living systems like plants. Numbers 3, 4, 5, and 6 are biogenic. They are produced by living systems, including plants. So number 3, bacteria. The bacteria that serve as condensation nuclei are emitted from leaves. Number 4, volatile organic compounds such as terpenes are emitted from leaves. See, how this works is that condensation only occurs when the water molecule, this is a water molecule, tiny water molecule, it can stick to something solid. So, such as number 5, pollen. So number 6, fungal spores. These all are, we care about this because this is the only way that rain can occur. If you want rain, you need condensation nuclei. It can be ice, it can be salt, it can be bacteria, it can be fungal spores, it can be pollen, it can be volatile organic compounds, but it needs to be some type of solid that can facilitate condensation. So the thing about, let me show you this graphic again. There's a tremendous advantage to having more of 3, 4, 5, and 6, and that is that the condensation occurs at lower temperatures. If you have only number 1 and number 2, salt and ice crystals, then the condensation occurs only at I got that wrong. Salt and ice crystals, the temperatures have to be very, very low in order for condensation to occur. You want the temperatures to not have to be so darn low in order for condensation to occur. So that's why we need more of 3, 4, 5, and 6, because condensation occurs at temperatures that are not so darn low, and therefore you have more. Therefore, more frequently you can have rain. So we want rain that is steady and consistent and gentle. We don't want long periods of time between rainfall. And when it does rain, we don't want it to rain buckets, because that, the dry spell causes problems and the downpour causes problems. We want rain to be more gentle and more consistent, and we will get that if we have more condensation nuclei. So I'm going to rifle through the rest of this, because it's been just about enough time. Trees emit condensation nuclei in the form of bacteria called aerobacter to form water droplets. All this goes away when we remove the forest. All of the benefits of a forest go away when we remove the forest. The condensation nuclei, every stage of the process, the evaporation causes, let me sum this up. So here are all the things we lose when we lose a forest. We lose the prodigious amounts of evaporation that occur. Evaporation means taking liquid water and turning it into water vapor, and therefore making it available for subsequent rainfalls. Also, when that evaporation occurs, when the plants and trees are emitting the water vapor, they are also emitting the condensation nuclei so as to cause condensation. We want the evaporation to occur. We want the condensation to occur because that causes cloud formation. We want the cloud formation to occur so we can have the precipitation. And all of these things are gone when we remove the forest. So I wanted to share that with you. That's just about all the time we have. Thank you so much for joining me. Have a great day.